Assalamualaikum and good day. You are with me again, Miss Huda. For this recorded video, we're going to learn on center of gravity. At the end of this lecture, the students should be able to understand the center of gravity, the methods to calculate the centroid of different shapes, and able to calculate center of gravity. What is center of gravity? Center of gravity is a single point about which the entire weight of the body acts. It will remain same irrespective of the position or orientation of the body. Center of gravity is considered for only bodies which have mass or volume. For example, a book. In terms of construction structure, we have beam, wall, column, or foundation. Meanwhile, centroid is a single point about which the entire area is acting for a laminar or plane figure. It is only applicable to plane figure having no volume. For example, a piece of paper, any shape such as the rectangle, square, circle, semicircle, and many others. The weight of body as a building or any part of the structure is always attracted by a gravitational pull of the earth through a point called center of gravity. To find the location of the centroid, the value is calculated by attaining the distance of the center of the shape towards the reference point. The location is known as X bar and Y bar. To calculate the centroid, we need to know the formula. First, the rectangle shape. To calculate the area, it is A, the area, equal to B times with H. And to calculate the centroid, if the reference point, which is point P, is at the center here, the distance to y-axis will be 0 and the distance to the x-axis will be 0 too. Kalau you letak the reference point di sini, the distance to the y-axis will be B divided with 2 and the distance to the x-axis will be H over 2. For trapezoidal area, the area will be half times with the height times with the length of the A and length of B, you tambah 2 lah, like this. And to get the centroid, if the reference point is here, the distance from the centroid of the trapezoid to x-axis will be this formula. However, there is no formula for you to use kalau you nakkan centroid of trapezoid ke y-axis ya. So normally what we do for trapezoid, kita akan bagi tu section. So you have section 1, the triangle, and then section 2 would be the rectangle, and section 3 would be the triangle. So it is much easier for you to get the centroid compared to kalau you pakai the trapezoid ni sendiri ya, sebab you hanya dapat the distance to the x-axis ya, to the y-axis. Tak ada formula for that. Next we have right triangle, which is 90 degrees if the reference point is here. Okay. Therefore, the centroid distance to x-axis will be 1/3 times h, And distance to the y-axis will be 1/3 times b. For scaling type triangle like this, which the all sides dia tak sama panjang, you can get the distance to the x-axis only, which is 1/3 darab dengan h. Tapi distance nak ke y-axis, tak ada formula for that. So sama juga for this type of triangle, we going to divide it into section usually, so that lebih senang kita nak kira the centroid. For circular area, this will be the area formula, or you boleh juga pakai pi d square over 4. And kalau the point P, which is the reference point, betul-betul dekat tengah, then the distance to the x-axis and y-axis will be 0. However, kalaulah the point P ni here, the distance to the y-axis will be r, and the distance to the x-axis will be r. For semicircular area, this is the formula. And to get the centroid, if the reference point is here, which is this will be x, this will be y-axis. So distance to the y-axis will be 0. Distance to the x-axis will be this formula. However, kalau you letak the reference point di sini, the distance to the x-axis masih lagi 4r divided with 3 pi. The distance to the y-axis will be r. For quarter circle area, this is the formula. If the reference point is here, the distance to the x-axis and y-axis will be 4r divided with 3 pi. For circular sector area, if the reference point is here, the distance to the x-axis will be 0. The distance to the y-axis would be 2/3 times with r sin theta bagi dengan theta. Usually when we calculate the centroid, dia ada macam-macam shapes yang bergabung, is a combined shapes. Jadi kita akan kena kira the centroid of shapes yang bergabung itu. Therefore, kita have to divide it into several sections. For example, you ada macam trapezium tadi, which is, it is much easier untuk kita kira. For example, kita akan bahagikan dia tu sections like this. So each section ni kita akan kira the area and then get the distance from x-axis, distance of the centroid of the section to the y-axis, darabkan x bar dan area, darabkan y bar dengan area, and you total up here. Then untuk dapatkan the x bar, meaning the distance from the centroid to the x-axis for the whole section, you ambil value ini bahagi dengan total area. And for you to get the distance from the centroid to y-axis for the whole area, you akan guna value ini bahagi dengan total area. So you understand what is centroid ya? Centroid tu adalah untuk shapes, untuk something yang tak ada mass. Okay. But center of gravity, dia ada mass. Untuk kira, biasanya dalam construction, usually wall lah. Because wall ni ada macam-macam shape. Jadi usually kita akan apply this one pada wall. You know that to get the volume, it is equal to length darab dengan width of the wall darab dengan the thickness. So it should be the area, meaning kalau wall tu rupanya macam ini, for example. Okay, so this is the area, and then you darab dengan the thickness of the wall lah. You will get the volume. And to find the weight of the wall, kita kena dapatkan the mass dulu, which is volume. Kita akan darabkan dengan the density of the wall lah. Depends pada material of wall, dan kita akan tahu berapa kilogram untuk setiap meter cube ya. So you darabkan these two, you will get berapa actually mass of the wall. And untuk dapatkan the weight, you kena darab dengan gravity acceleration, which is 10 meter per second power of 2. Baru you akan dapat dalam Newton, which is this one adalah weight. And bahagi dengan 1000 sebab kita nak tukar tu kilonewton. After that, kita boleh dapatkan reaction dekat support by using the moment equations yang you belajar dalam principles of moments. I think that will be all for this introduction to the center of gravity video. Bye.